This is, I want to remind everybody to keep your mics muted if you're not speaking, please. This is IC 69 Smart Wheelchairs, what's available for power chair safety with Michelle Lange and Gene Minkel. I will give out the CEU code at the end, and I will also put it in the chat box. So be on the lookout for that, and I will turn it over to you guys. Take it away.
Great. Thank you so much, Joseph. Appreciate it. So welcome to this course here today on smart wheelchairs, what's available for power wheelchair safety. And we very much appreciate you taking the time to choose this course here today. And or if you're watching it as a recorded offering later on, we really hope this information is helpful to you and the clients that you work with. So I'm Michelle Lange. I'm an occupational therapist in the Denver, Colorado area, and I work quite a bit with power mobility. And so anything that comes along that could possibly help someone to drive better than they are, or maybe drive at all, is always very, very welcome in my book. So I'm very excited about some of these new smart wheelchair technologies. Jean, you want to introduce yourself?
Yes, my name is Gene Minkel. I'm a physical therapist with background and training, and I've worked in the seating and wheel mobility world for quite a long time now. Today I am sitting in front of a background that says On a Roll, which is the wheelchair clinic that we run in New York City, supporting people with physical disabilities to be as independent as possible. I'm a Caucasian white woman with gray hair, and today have a white turtleneck and a periwinkle, something to keep me warm because it's really cold outside, with a little wheelchair colorful pin that comes from San Francisco and celebrates the folks that we support in being as independent as possible. As our disclosure, both Michelle and I provide consultation to Lucy, as important as this topic is about smart chairs, and Lucy represents one of the smart products.
Great. Thanks. And if you have any specific goals, something you really want to make sure we touch on here today, feel free to pop that into the chat box. If you think of questions and comments as we move along, put those in the chat box as well. Most likely we will wait and get to all of those at the end, but type it in while you can remember. It's after lunch and it's a tough time. Here's our learning outcomes that we will be endeavoring to meet here today. So as introduction, whoa, let me mute this here. Where is mute? There we go. So, you know, we've all heard about smart technologies in cars. We actually got a newer car this year, and it has more of these features than I've ever had before on my 14-year-old minivan. So we have blind spot cameras, we have blind spot monitoring, we have rear cross traffic alerts. So if I'm going to be backing out of my parking spot, I get a warning. There might be a warning that I'm departing from my lane, or assist to actually keep me in the lane. There's brake supports that will either slow me down as I approach someone, let's say I'm in cruise control, or might stop me altogether. So we've all seen the commercials. You might have a vehicle with some of this, but the real goal here is safety. And what I think is important to keep in mind is this is all designed for drivers who should have typical motor, cognitive, and sensory skills, and yet still get into accidents. So we know research has shown that this improves safety and reduces those accidents. Well, what about the world of powered chair? Well, smart wheelchair technologies bring similar features to the area of power chairs, and this is provided along a continuum. And one of your handouts is that continuum itself of how products fall out right now, and we'll be addressing that. But it's always nice to actually start with an example. So in case you're not familiar with some of this technology, this example is of Lucy.
Introducing Lucy, revolutionary patented technology for power wheelchairs.
Hi, Mom. Hi, honey.
Lucy believes in real-world technology inclusion.
Alexa, ask my Lucy if my chair is charging.
The battery is approximately 80% charged.
an incredible driving experience with cutting-edge drop-off protection and hardware and software providing first-of-its-kind collision avoidance for your world to wheelchair better, safer, faster, and smarter.
The cheese!
Lucy is modern mobility,
It's called Lucy. It's attached to my chair. And it knows where all the curves are.
and that means more independence, more fun, and a chair that finally listens to you. With a HIPAA-secure platform and app for the information you care about. Wheelchair smarter with Lucy.
So that gives us some context as to just what this technology is. So in this section here, we're going to talk about the need for this technology, the technology itself, and wrap that up with the person. So starting with the need, I'm going to turn this over to my more than capable partner in crime, Jeannie Minkel.
Thanks. Can you forward to the next slide for me, please? So, we've been involved in wheeled mobility for many, many, many years. And our fundamental goal is really looking for opportunities that somebody can self-generate mobility. And for someone who perhaps is having some limitation in ambulation, we ask, how would their ambulation be with or without a mobility aid? Are they functional with ambulation aid? Are they actually safe? And I try and make this as functional as possible. And so when I'm looking at someone's ambulation and asking if it's functional, can they get across the street while the walk sign still says walk? In a community setting, that's just a really practical measure of whether ambulation with an aid is still functional. If it's not functional, as we go through our quote least costly alternatives, we start looking at manual mobility. Is that optimally configured chair? And really the key there is optimal configuration. Can the person safely maneuver their environment and get across the street with the walk sign on when they're pushing a chair? And if that's not functional, it brings us to power mobility. And the changes slightly with power mobility because we want to be sure someone has a consistent control method. And I remember early in my career coming to the realization that in looking at self-generated mobility, as much as I was looking for an access site, I really wanted to know if the person could safely stop. Could they release the control as efficiently as they could access the control? So when we talk about power and we ask about what's functional and safe, can the person make it across the street? Yes, that's good. Can they do it without being a danger to self or others? And that's where a clinical decision and a real context comes into play. And it's where I really start thinking about what are we offering if we have concerns about danger to self or others. Next slide. So power chairs do have some limitations, and it was really interesting this morning. I was part of the session with the folks from Shepherd, and they were looking at the Fit tool and helping end users figure out what type of device was going to work in their global world. And transportation becomes one of the big questions. Will I be able to have a van with a lift? Or do I really need to consider a manual chair because of the transportation? So if a power chair is the best method of self-generating mobility, it does introduce issues around transportation. And that van access is a whole nother safety issue with regard to the edge detection. Are you visually, perceptually safe as you are coming on and off that lift or ramp? One of the bigger accessibility issues is, can you get around in the environments, be it a public environment or your home, and in crowded places? And that takes now visual, perceptual, and motor control as you want to go quickly because you have a place to go, but there are 4 or 5 people stepping in front of you. you have to back off of that joystick. You can't be going at 6.5 miles an hour through Grand Central Station at the peak of commuting hours. For some folks, it can be very energy costly in trying to maintain a straight path, especially with alternate controls. And we'll talk some about how some technology can make that energy efficiency less. And then most importantly, just as Michelle was talking about, automobiles are providing safety systems, and yet we know a lot about where the automobile is actually driving. It's on a road. There are some criteria about the environment of use. In a power wheelchair, it's being used every place that this person wants to negotiate in their world. So it's a world full of obstacles and drop-offs and inclines, and those obstacles may be stationary, like walls and doors, or they may be transient, like dogs and babies and kids and family jumping in front of somebody operating a chair. So power wheelchairs are complex environments to think about safety systems. Go ahead, next one. So what does present a danger to self and others? There are lots of environments. So we have to be cognizant that the person is taking in the environment of use. What can get in the way of safe driving? Well, poor motor control. If you have a hard time keeping a steady input into a joystick, then perhaps an alternate control is a more efficient way. In that alternate control, do you have a very efficient way to stop, especially if you're stressed? So stopping is one of the key features when we think about safety. Is the person's not only their acuity, but are their perceptual skills and a loss of a visual field? Is that impacting their safety? A power chair by itself has a lot of mass, and now you have it moving. So mass times acceleration equals force. You have something that could inflict if the person's reaction time or perception or visual field loss prevents them from being as observant in their environment as we would like them to be. I mentioned reaction time, not being able to process the information fast enough. And then what's the level of distractibility? And I think part of the reason we have increased safety systems in automobiles is because we have cell phones in automobiles. There's such a level of distraction between the GPS telling you where to go and the incoming text, and I don't really like the song that's being played on my playlist, when what we should be paying attention to is driving. Well, a person that's getting around in their world in a power chair, there's lots of distractions. And if they are distractible before they were ever driving, danger exists. So what are the concerns? Well, our current complex rehab power chairs are not built to prevent a collision. It's totally relying on the user, and the user in what I'll call an optimally configured power chair. Have we programmed the chair to best meet their motor control needs? Have we programmed the chair for acceleration and proper braking? But inherent in the chair itself, we're asking the person to avoid the obstacle, not to hit people or walls or doorways. We're asking them to be sure that they're aware of the curb to prevent a drop off. We're asking them to be cognizant of what kind of a unsafe angle, not only straight up and down on a ramp, but side slopes. So get enough speed going, have a steep enough incline, you do have the problem of tipping over. So right now, we're relying on the driver to note the potential hazard and then avoid them. The picture.
Oh, sorry, let me go back.
That's okay. I have the absolute fortune of being able to work in a community-based seating and mobility clinic. And I can tell you, even if I've never been to the person's apartment, I can tell you which apartment they live in by virtue of what the walls and the doorway look like going in and out. So you'd be surprised how often the home environment is subject to these. They might be relatively low level, but they're crashes that are impacting the environment and impacting the chair. Go ahead, Michelle. So what are the outcomes of our current designs? Well, there's some really fascinating studies. This is out of Archives of Physical Medicine in 2011. Wheelchair users, 87% of them reported at least one tip or fall in the last 3 years. That's a safety concern. We have data that says that for children who use mobility aids ages 2 to 10, 67% of the injuries were related to falls from wheelchairs. Now, is it moving or not moving? We have to dive into that kind of data. Next slide. What's really important is if someone is falling from the chair, particularly if it's a moving chair, then the significant risk of mild to severe head injury exists as a result of a tip or fall accident. And I know that we spend so much time being sure that we're doing a good match between technology and the person and their needs. I don't know how often we ask people, have you had a fall out of your chair? What has been your personal experience? And over half of the accidents reported were a result of hitting a stationary object or encountering uneven terrain. So it's a really wild world out there, and we really need to start paying a little bit closer attention to what are our users encountering and what technology are we offering to help them be safer. Next one. So I've become much more aware of asking what's going on. And I encourage you, ask any power chair user, and I'll bet they'll have at least one crash story for you. A wonderful dear friend reported to me when I saw she had broken her leg. She had missed the edge of a portable ramp as she was going out of the restaurant, and the chair went over, she went over, and the result was a broken femur. And this was a woman in her 50s who had driven a chair for 50 years. So it wasn't somebody new, just was an unusual environment of a portable ramp. It's also really interesting to ask people, how did the foot plate get bent? How did the joystick box get broken? How did that hole in the wall happen? I guarantee you there was, I ran into something or I drove off of something. So the need is there. And now we need to really start asking, what solutions can we start to offer people? Next slide. There's also a really interesting, particularly if someone's had a bad experience or they've driven into something or they don't feel like they have as good control of their chair, perhaps because of a progressive condition, to really ask people, how safe do you feel operating this chair? How confident are you as a driver? And we find we have some really confident drivers. They're race car drivers. Their chair is an intimate part of their body. And there's very little concern of their confidence. And they often have earned, if you will, the confidence of driving safely. But then there's some other folks who, if we don't ask them the question, we may not know, I really haven't used the chair very much because it makes me nervous, or I'm really scared to go out because I'm afraid I'm going to hurt somebody. And those are the probing questions we need to follow up on. Next one.
All right, we have a lot of great questions and comments already. So we're going to totally ignore you. No, we really don't want to. And I see some people are answering each other, and I appreciate that because we have all these amazing people on this course here today. But we're going to keep plowing through so that we have time at the end to get to all of those. So we're going to turn to the technology. And, you know, whenever something is a newer technology in any field, it's very important to define it in context of the existing technology. So it was important to come up with just what is a definition of a smart wheelchair. Well, this definition is as follows: integrated or retrofitted self-monitoring technology for a power wheelchair, which provides enhanced independent mobility to a wheelchair user and is able to collect and report user health and wellness data and provides connectivity to integrate with the connected world. Now that is quite a mouthful. So what does that really look like? You know, we're already halfway through or more our second day of ISS, and your brains might be getting a little mushy. So let's give some concrete examples here. This technology is along a continuum. So smart wheelchairs may include any or all of the following: sensors that warn the driver you're about to run into something or go over something like a drop off, a backup camera that also can warn the driver of a potential collision, tracking technologies that increase driving efficiency, sensors that actually not just provide a warning, but actually prevent a collision or drop off, but still allow independent driving, sensors that monitor the environment and modify speed to allow driving without collision, but still allow independent driving. And then finally, sensors that follow a pre-programmed map or a tape on the floor for nearly automated driving. So you can see there's quite a continuum here from warnings to nearly automated driving. So we're going to now look at some of these examples. Also important to remember that in addition to all those really cool options, smart wheelchairs can also provide a communication with external devices using apps and can even monitor the driver's health information. And I think this will only increase. So one of your handouts is a smart wheelchair automation levels. It's a little hairy unless you really dig on things like this, like I do. I'm geeky that way. It's something that I'm sure will continue to change. And so hopefully we'll get this up on the Lucy website, and it could be something that you can revisit at times to see what those changes are. So if you have that handout, feel free to crack it out. Otherwise, you should be fine without it for now. So at the beginning of our continuum are actually products that have no automation at all because they're not integrated with the power wheelchair electronics. The driver is in full control, but the sensors or a backup camera provide a warning to the driver of a potential hazard. The onus is on the driver to respond to that. So our first example has actually been around for a long time. These are photoelectric switches from Adaptive Switch Labs, and they're available in a 2 or 4 switch array. So you can put 2 on the front or 2 on the back, or have them front and back. If you get close to an obstacle, you'll hear an auditory tone. There's a different tone if you're using all 4 to let you know whether the obstacle is towards the front or towards the back. And you can adjust the sensors to elicit this tone, play this tone between 4 and 24 inches. It's not designed to detect a drop off. Raise mobility, and they are in the exhibits, their virtual expo there. So I would encourage you to check these guys out as well. Use ultrasonic sensors. These can be placed at the rear, sides, or front of the wheelchair. And the feedback that's provided can be visual, it can be auditory, it can even be haptic, where the driver of the power wheelchair feels vibration, similar to some automobiles where you actually feel vibration if you're getting close to the lines on the road. The sensor shown on the bottom here provides 180 degrees of horizontal and 50 degrees of vertical coverage to provide feedback. But again, this is something where the driver needs to respond to that feedback. So let's take a closer look at the Braze mobility system by hearing what a couple users have to say about it.
I've been in a wheelchair just over 2 years.
I've been in a wheelchair for 25 years now. I injured myself in an ATV accident.
2 years ago on Christmas Eve, literally they dropped this wheelchair off to me. Within hours of me getting in this place, I had pretty much destroyed my apartment.
Done a lot of damage in my house and on my furniture and knocked a lot of things over unintentionally. And after a while you just start ignoring it because you're either constantly frustrated with the damage you do, and so now it's kind of like 2 or 3 dents in the wall a day is just normal.
To have a device back there that is literally watching my back is an amazing feeling.
When we added this sensor unit to the chair, it was just amazing it gives you an alert before you hit something, because you don't do it intentionally. Like I said, it lets you know where you are. When your back is through a door frame, I can tell if I'm centered in the doorway because the sensor's detecting both doorposts as I go through.
So I can actually back out of there just by looking at the lights and no longer rip that. The door handle's actually been on there ever since this device has been on my wheelchair. It's never been taken off once, so that's a record for me.
So that gives you an idea of the Braze system. We also have a variety of backup cameras. We probably all have heard of the Quantum Rehab new backup camera, which is available, but there's also a couple other companies that make backup cameras that can be added on. Again, this just provides some visual feedback. The driver has to interpret that visual feedback and then respond accordingly. Then we have another category as we move along this continuum called driver assistance. And these are technologies that are actually integrated with the power wheelchair electronics. So the driver and the system share control, and there are several product options under driver assistance. The first is an emergency stop. Now we have emergency stop switches out there, but they're not integrated with the system in terms of a sensor notices something and stops the chair. So that's not represented by a product option right now. It's a possibility, but it wouldn't make much sense if the client can't get up and driving again. Tracking technologies have been available on chairs for a while to improve efficiency of driving, and that's a form of driver assistance. And then there is a newer option available to assist with steering and with speed control. So tracking technologies, yep, this video is going, have been around for a while, and these are usually an optional feature, which is frustrating because that means it can be denied, or sometimes we forget to go ahead and order it, but it reduces the amount of joystick movements or switch activations that are required to get from point A to point B. And that also reduces the amount of time. So this increases driving efficiency. It's really important for people who are driving with alternative driving methods, like our client here who's driving with the head array. So steering and speed. If sensors detect an obstacle or a drop off, the power wheelchair will no longer move in that direction, but the client can still drive, just not in that direction. So for example, if someone wants to go through a doorway, I just go through that doorway, and the sensors, by assisting with navigation and speed, will prevent me from hitting the door frame in any way, shape, or form, but I still can drive actively through the doorway. So this is not automatic driving. The client still has control. An example of this currently is Lucy. So we're going to watch a video of a gentleman who lives in my area and how Lucy has helped him with navigation.
Still want to keep Lucy, or do you want to turn her back in?
No, I don't want to turn her in. No, that's not a really. It's useful.
It's useful. He hasn't not run into anything since he's had Lucy, and that's a good thing.
See, the dog is in the way.
And People like me love that. People like you love it too.
We're not going to run into the walls. I feel safer.
One cool thing about that video, besides it's just an amazing video, is for this particular gentleman, he is much more confident in his driving. So before this intervention, he was driving very slowly, like just so slow and in limited environments. And his world has opened up. Now he's confident enough to drive outside his home in a variety of environments and at a more reasonable speed so that the person with him can actually walk at a more typical speed.
Still want to keep it?
There you go. All right, Jeannie, you want to take it over?
Sure. Just one comment in the difference between the two systems. The gentleman who was talking and showing how he was backing out of his kitchen and not hitting the door handle, which was a first for him. He was adapting his driving skill based on the lights telling him where he was proximate to the obstacles in his environment. The gentleman that was just on the video, the chair won't let him drive to the direction in which he would hit something. So there is a feedback loop that the obstacle was detected and the chair's response is modified. And to do that is using a millimeter radar system. And this is what the automobiles are using. And I just wanted to point out that it can be used strictly for a alert. So there's a blind spot detection. It's just telling you, be careful, there's something there. You can still steer into it if you want. But if you think of the adaptive cruise control, that's where there's a feedback loop coming. So I have cruise control on my car. I have a safety system that if I get closer to the vehicle in front of me, the car will slow down. So that's where this self-monitoring and response comes in with regard to smart technology. Next one. So if we think about that automobile application and we apply it to power wheelchairs, and we want to be able to look at the environment that the chair can go in, the radar will only pick up objects in the environment. It won't be able to detect drop-offs, and it has some limitations in terms of distance and environment. So the fusion system is using multiple sensors, using cameras, stereo vision cameras, to allow us to map the world in front of us, to be able to detect drop-offs and curbs. The radar is picking up objects, and the ultrasonics let us see things that wouldn't otherwise be picked up. So we can, ultrasonics will pick up the objects. Radar will help us do it in dark environments or when the ultrasonics are not successful, like a soft a curtain or a soft material. It's only when you combine all three can you really get a view of your world that then allows the user to stay in control, but the chair will modify and stop you. It'll slow you down first, give you information, or if you don't pick up on it, it will actually stop the chair. Next slide. So acceleration, deceleration is obviously part of the steering and speed. And if the sensor picks up an object, it will slow you down. And just that slowing down, often for particularly a distractible person, oh, wait a minute, I feel something different. Ah, I see there. I'm a little too close to the doorway that I'm trying to turn in. So if I respond and take a modifying approach to into the doorway, I can keep driving. There's no problem. It will let me drive in the direction opposite the obstacle. If I don't respond and I keep going, then the smart device will actually stop the chair. So we have an example here of how this can be used when a power chair is being used with a crowd of people. So go ahead.
When we simulated walking in a crowd, for some reason that stood out to me because it made me realize that this is like an unbelievably normal, typical activity for somebody who's not a wheelchair user, that somebody who is in a wheelchair gets nervous and feels like that they can't be a part of that because they're afraid they're going to bump into somebody. That is what inclusion is supposed to be about.
And again, a really subtle thing about that moving in a crowd, when the operator was in the chair, they maintained their same joystick position. So the joystick position was, if you will, in full throttle, but the chair only moved at the pace of the people around them. And this is certainly a feature in a crowded environment like I work in New York City, where it can get people crowded pretty quickly. And the chair will respond and not run into the back of the person that just stepped in front of you. And we have lots of laughs in the city about how ineffective the beep button is of your horn. Yeah. The person didn't hear that. And so that puts the control on the user to back off of the joystick. With a smart system in front, just like that adaptive cruise control, their joystick stays in the same position, but the chair maintains the safe position within the crowd itself.
And Jean, I work with a lot of children, and I tell you, driving down a crowded hallway in a school is worse than driving on a freeway. It's horrible. So you've got kids who are suddenly stopping and changing direction and running in front of you and everything else. So I love the crowd control.
The other acceleration, deceleration that is really important and really much more complex than you may think. If the drop off is outside of what the chair's designed to do, then we want the chair to stop. But we know that the world is not flat, and we don't want the chair to stop at every drop off or curb or incline that is within the capability of the chair. So the system really does need to be smart and be able to calculate the difference between an unsafe drop off. So in this particular case, driving forward is greater than the chair's allowable. So a 4-inch curb, I want the chair to stop before going off the 4-inch curb. If I turn the chair around and I want to go up the 1.5-inch curb, that's within the capability of the chair. So I don't want the system to stop me. I want to be able to function within the capability of the chair. Next. So what are some options across the spectrum? Well, if you have good vision and good reaction time and frankly good motor control, but you don't have eyes in the back of your head, because most of us don't have eyes in the back of our head, a backup camera and a warning system and an obstacle detection system with signaling can be the perfect option to improve your driving experience, particularly in tight environments. If you're having a hard time and you find it really energy consuming to maintain that straight course, that's where tracking options can come in. Tracking technology and being sure that that is ordered at the time the chair is ordered, because it's a form of regulating your speed and steering to make it a more efficient driving capability. If there's any concern of danger to self or others, or the person has fear of driving, or maybe their caregiver has fear of them driving, we see this a lot. Like I always ask, how come the caregiver's driving more than the person is actually driving? That's where the fuse sensor technology with driver assist may be an application. Next one. So what Lucy is providing is really that keep the user in the loop. the user is going to decide how to use the information that's being provided. If you're on an incline, it's just going to give you a auditory warning and a visual warning. And there's no automation. It doesn't change how the chair performs. It detects an incline. It alerts the person that you're on a steep incline. You're probably on an incline steeper than what the chair was designed to do. You may want to back off of that very steep incline, but it doesn't automate the response with regard to the chair. When it comes to obstacle detection, this is where it is driver assistance that then moves to driver protection, but it always gives the driver control. So when the obstacle's detected, the speed of the chair is reduced. Therefore, it allows the braking distance needed to be reduced, and we can avoid the collision. If the driver doesn't respond, if they maintain their control, Lucy will stop the chair, and it'll stop the chair in order to protect the driver as well as the chair itself. And at any time that Lucy stops or slows, the driver always has the opportunity to override. So there's an override button, and the override feature can also be an additional switch. So even for alt control drivers, we always give them the opportunity to override. And a really classic example is many people need to use their foot pedals to get through a door. And if the system stopped and you had no ability to override, it may be Medicare's dream. There you are in the home. You are stuck. You can't get out because your smart system isn't giving you the opportunity to override it. But user in the loop, we always get to give the user a chance to assess the situation and then take ownership. Same with drop-off detection. It will prevent driving in the direction where the drop-off has been detected, but it'll slow the chair first. It'll give you a first notice, hey, look out. And then if you don't respond, it will stop you. It won't let you go over the curb, but you can override if it's something that you're familiar with or you know what's happening. But frequently, that's the real avoiding of the tip over that's going to cause the catastrophic problem. So stopping the tip off. So on the conditional automation, so now we've taken the user out of the loop and we're starting to get into some more autonomous driving. In this particular system called the Smile Start system, there's a path that's located by a tape on the floor, and the person initiates the movement and stops the movement with a switch, but the chair itself is following the tape and following the line into, perhaps from a bedroom to a kitchen, a known location, and it prevents collisions by having sensors, but also staying on the path. So by staying on the path, we avoid collision, and it gives somebody the method of moving through their environment, even if they aren't able to volitionally control all the directions of travel that would be needed. Next one. The one last thing that we think about when we think about smart chairs is conductivity to and integrating into a connected world. And this is where we're starting to see some of the wheelchair manufacturers providing apps that connect back to the functionality of the chair in order to empower the end user to know what's happening. So all the complex rehab chairs are now offering Bluetooth, which can provide switch access or mouse emulation to chairs. Next slide. We're seeing apps now come. The My app, My Permobile, allows someone to connect to their connected chair. And what's really interesting here is the manufacturer has sent this out in the default mode of not being on. So the user has to opt in, which is really an important step because someone needs to know that they're sharing their information. But if somebody opts in, your connected chair now allows somebody to track their battery status. They get to look at the distance that they've traveled. If they have power seating functions, they can look at their seating activities. And we start putting that data into the hands of the end user. And the other great feature, if you've opted in, is you can get remote diagnostics out of a connected chair. Quickie is now offering the Switch It Remote seating app, and it measures again and tracks the seating angles. And this is the beginning of data that's going to help us know for this individual, what's the frequency and what's the amount of changes that they need to make in order to control their pain, maintain their skin integrity, hopefully increase their sitting tolerance, be as productive and participatory in life as they want to be, because they have information that's real life, real time, in the world information that they're interested in. Next one. Just two other apps that I think are so useful for end users. The push tracker that's part of the Smart Drive from Max Mobility and Permobile. It'll track your distance within a day and how far you've traveled and what are your distance per push. You know, one of the things we're trying to do is protect people's upper extremity for longevity. So conserve to preserve. And here's data that's telling you, are you actually propelling using a conserve to preserve? And how much force are you putting on when you are propelling your manual chair? Next one. Similarly, Smooth gives you information and it allows you to adjust your driving modes on the fly, keep your eye on your battery life. And then with an upgrade, the app actually gives you a navigation feature that helps you determine the most wheelchair friendly route for your destination. So you could start to see where these connected technologies, and we start thinking about smart cities, and you know, if you can find the friendliest route, are you avoiding the steep inclines? Are you avoiding the drop-offs? Are you having a safer mobility and saving your upper extremities as well? So next one. Lucy began, I think, some of this push towards the connected world. And as you saw in the first video, again, if you opt in, if you put your My Lucy on your phone, you can connect to a virtual assistant, to Alexa or Google. And with that, I can ask, what's the condition of my battery? I can also decide who I'm going to share my information with. So I may want my personal care attendant to know that I am off because I did miss that tilt signal and maybe I did tip over and I want someone to know where I am. I can share with my therapist what my seating performances are. What is the condition of my cushion? So I can opt in, I can choose who my teammates are, I can share information, and I can also tell people, give people permission to know where I am and set things like offloading reminders. This data can also be connected to some of our smart technology. And Barry, who spoke at our plenary, was speaking about the information that he and his wife and care team really look after in terms of their daughter. And what they found was Catherine doesn't often tell them when she's in distress, but her heart rate will tell them when she's in distress. So her smartwatch detects her heart rate can be connected through the My Lucy, and then mom and dad can then inquire, what's happening? We see that your heart rate is starting to peak. So the power here of thinking outside the box is really amazing when we start thinking about the person, their device, and connecting that smart chair to other health and wellness capabilities. Next one.
Did you want to mention Lucy Air?
Not for this time.
Okay.
I'm cautious
Yeah.
of time.
I know we have a lot of questions.
Just as one last thing, as part of your handouts as well, this continuum and this concept of where are we in understanding smart technology, particularly in the complex rehab world. It is a great conversation starter, is a document that was put together by Jared Dean, the developer and chief technical officer, and it's called Judging Smart. So we highly recommend folks to pull that down. It's a PDF attached to this workshop. It's also available on the Lucy website. It's available in hard copy. And it's a great framework for asking, where is smart technology in the power mobility world today?
Yeah, and this is absolutely not a commercial for Lucy. This is designed to start a conversation about this is a newer technology in our industry, and we all need to collaborate on this technology as it continues to evolve.
And earlier today, just back one more.
Oh, yeah, sure.
Earlier today, I attended a session on smart homes and smart home platforms and what's compatible with what. And that industry has moved towards a standard for defining these things and having a common language. And I think that's the beginning of our conversation here, is how do we engage in a conversation around smart and start developing smart standards.
Absolutely. Well, we're going to skip over our last slides because there's so many great questions. We really want to get to that, but certainly in your handouts. So I'm going to start going through some of these, Jane, and we can just trade off here. So I've got a good one for you because I don't like answering funding questions. How to get systems covered by insurance considering in-home use limitation? Any suggestions? I know, isn't that your favorite Medicare regulation?
My favorite Medicare regulation. Yeah. And what's very interesting is, one of the places that a smart device is most useful is in a small, tight environments that are often encountered in a home. So I don't want to limit the justification to the home, but there certainly are in-home reasons. And I would again go back to the user. Have they had experiences where they might be what Kendra was calling earlier a minor event? It just was a broken toe. Yeah, it was a broken toe because you ran into the wall in your house, or you missed the corner getting into your bedroom. So in-home shouldn't be a limitation. It should be a place of inquiry. And then if the further application is in order to negotiate their outdoor environment, I think it's really important that we make the requests as they reflect our consumers' needs. People are negotiating in the community. And how do we allow for full participation? We allow for them to go where they want to go, when they want to go. And if they need a safety system to do that without posing danger to self or others, then this is a necessary item for them to be able to have self-generated mobility. And self-generated mobility is a human right. So now we have technology to allow someone to negotiate their world as independently as possible. So make the pitch.
Yeah, and that really partially answers this next question from Kathy, wondering if technology like Lucy might make it difficult to get funding for a chair, since insurance may want people to demonstrate they are safe in a chair. I totally hear you, Kathy. This was one of my initial first concerns. It's hard to get funding for a power chair, especially that first power chair. It can be very difficult for children like I work with. What we have available is a funding toolkit on the Lucy site that does help address some of these concerns, because that's definitely a great and valid question. What I think, and this ties into what Jean just said, is that this is a technology that can help people to drive better and safer. So I think there could very well be some people who couldn't drive at all without technology such as this. But even in that case, this allows that independence in mobility that otherwise we wouldn't have. It provides that safety so this person can use the chair. So I think that would be some of the answers there. Peter has answered some of the coding and funding questions, so thank you very much. And let's see, Vita has said, can you predict if in the near future all major manufacturers will incorporate these safety features into their power chairs similar to the auto industry, or is it cost prohibitive? You want to take that one, Jean?
Sure. I don't think you can ever pit cost against safety. And my hunch is, as technology, so for using the exact example of, as it's in the automotive industry, and something had to push it, something had to get it started. People dying in accidents pushed it and got it started. And now the availability of the technology makes it more accessible. So the fact that it has been proven as a proof of concept, the price will only go down. But more importantly, what we want to be sure is that it's being applied for the persons that need it. So I do believe this will start to push greater integration across multiple manufacturers. And we're already seeing it in the apps. There's much more user information coming to the app. And I really want to encourage people to think of this as a continuum. I mean, there weren't backup cameras on power chairs 2 years ago. There have been backup cameras on automobiles a while ago. So sometimes it's leveraging what another industry is doing it and then applying it to our own industry. But more importantly, what do our end users deserve? And how do we then make the case that allow them access to the technology that they deserve?
Yeah. Donna's asked, does Lucy work with the VA? And yes, they do. Great question. And someone else has said, we still seem to have a little ways to go with smart wheelchairs for developmental disabilities to practically use well, but the progression of this technology development is promising. Great point. I work primarily with people with developmental disabilities, and we kind of skipped over our client section, even though it's very important, just because we have so many great questions. And I think a very appropriate client for much of these technologies is someone who perhaps has motor limitations, hence the power chair, hence perhaps an alternative driving method, cognitive limitations, as well as visual limitations. So I think that for people with developmental disabilities where there may be multiple impairments, this can be very, very useful technology. Donna has said, I worked with the Narayan industry system, which was an external system similar to Lucy. And the drop-off system worked for curbs, but not for sloping drop-off. I'm not familiar with that system. Are you familiar with that, Jean? The Narayan? I haven't heard of that one. Donna, feel free to put in the chat box if that's from perhaps out of the country. Byron, hi Byron, has said many times property damage and accidents can be prevented with adequate programming and driver control selection as well as positioning. Excellent point.
Absolutely.
I really don't know why chairs are programmed the way they are out of the box, because they're all too fast and too perky for my liking for a new driver. I think they need to be set up for student drivers and we can move them up from there. But programming is very important, finding the right driving method, training, positioning, all very important. Pamela said,
just pause
oh yeah,
there.
Sure.
Training.
Yes. Yes.
I cannot stress enough that that it is a responsibility, if you are providing a device, to provide the mobility skills training for that person to use that device in the environments of choice. And yes, programming, and unfortunately, what you find is people have the accident before they come back and get the chair properly programmed. So
Absolutely.
please take
Well,
the time.
we are almost at the end of the session now. I'm going to totally speak for Jean here, but we're very willing to hang out and answer questions if you're able to stay on longer. But let's let our moderator wrap this up and provide that secret code, and then we're very happy to continue the dialogue.
All righty, guys, thank you very much. The CEU code for this session is HUWIIX. And I will be jumping off since I have another session to moderate, and we do have one more hour block starting at 4:30. So thank you guys very much for another great presentation. We appreciate it.
Thanks, Joseph. So for those of you who can stay, Pamela has said, does the Lucy system recognize drop-offs at a pool side or just curbs and ramps? I think that's the beauty, as Jean was talking about, with these multiple sensors, is what one sensor can't detect very well, such as water or light reflecting off of water. That might interfere with some sensors. Other sensors can. Do you have anything to add about poolside? I haven't yet experienced. I haven't aimed at the side of a pool in a Lucy system yet.
I mean, the answer is the sensor can detect it. The question is, are you traveling at a speed that is impossible or possible to actually stop? So this is where technology cannot take the place of common sense. And if somebody is poolside, then it will slow the chair down. But if you're traveling at a rapid speed on the edge of a pool, there's no guarantee that it will stop you. But hopefully the person that has been provided that device has sufficient capability to make that judgment.
Great. Holly has said, does Lucy recognize drop-offs that are to the side of the chair to avoid turning into it, or only in front of the chair? I have a client with CP who uses a power chair and needs to drive through a narrow hallway at the top of the stairs to get to her bedroom. Currently, someone else has to do it for her. So as you probably saw, Holly, in the one graphic where Jean was explaining the sensors and that coverage around the system, there are sensors that cover sides, front, and rear of the chair.
It is a 360 map.
Yeah. Peter's answering some folks for us. Yay, thank you. Darcy has asked, I'm interested in this technology use in the pediatric environment with children with cortical visual impairments. Any experience or recommendations with this population? Well, the topic of power mobility and CVI is, gosh, a whole course in itself. That would be an excellent course. There have been some courses like that. There's certainly certain strategies that can be helpful in mobility, but I think personally, because most of my clients have CVI, that this sort of smart wheelchair technology has huge potential for people who have vision, but not always the acuity or the perception or the processing to safely drive without some assistance. Each situation, of course, is very, very individual. So great question. Hey, Steve. Steve has said systems like Lucy and Braze sound like they would be ideal for alternative controls configured for latch driving or eye gaze systems. Are they compatible? So Lucy is compatible with eye gaze. I believe Braze is as well, because Braze is not integrated into the chair. Remember, it's a warning system. So in some ways, Braze isn't dependent upon the driving method. Last I knew, Lucy is not working quite yet with the latch feature, but it's something that they are working on. Do you know anything new about that, Jean?
On the development board, but use it. So Lucy's compatible with all controllers, with the exception right now of latch. Not to say that it can't be developed, just not out the gate.
Yeah. Oh, and thank you. I think that's Barry has answered. Somebody has answered Steve about latch and alternative drives and all of that. So thank you. Donna said, so is Lucy an aftermarket thing you can add on an existing chair, or does it need to be installed when you order one? You can absolutely install it afterwards, but it has to be a compatible chair. And there's a list of compatible chairs on their website. If you don't see that, on their site, then definitely contact them, because the more people that say, I really want to work on this chair, hopefully that moves that chair up in priority to make sure it works. Let's see, and we've got, thank you. Tom's also answering some questions. Appreciate that. Susan has a good comment here. I don't think all users realize the danger of using a power mobility device. We need to educate them. I once had a client who is accessing a hotel electronic door key and drove into the glass at the side of the door into the hotel, shattering it with his footrest. Oh, I feel your pain. Been there, yes. Just trying to go through here. Are you having success getting Lucy or others approved by insurances? You want to take that, Jean, while I scroll through to find our questions?
Sure. The answer is yes, we have had success. And as mentioned earlier, the VA is processing requests, obviously based on individuals' vets' needs. And Medicaid programs, we've had success, particularly when the need has been directly linked to increasing the person's independence in their own mobility. The Medicare, for those of you who are in the States, we are using a miscellaneous code right now. So you do need to make a very individual justification for the device and put it through the system and appeal as needed. But we're getting excellent responses when it is clearly defined as to why this person will be more independent with the device, with the safety system on the device, regardless of which safety system. It's linking it to the person's mobility.
And Tom mentioned in the comments as well that he also provided some funding information and directed folks to some resources that are on the Lucy site for that system as well. Alyssa says, my new motion rep said they can't supply Lucy. Has anyone else had this experience? I'm going to throw that your way too, Jean.
So New Motion has decided not to process orders. Then it really has much more to do with the processing of the order. And so I would really encourage anybody who is working with a client, if an alternate provider in your area should be approached, as there are independent reps that can provide demos for you, and other suppliers are processing the requests. It's a corporate decision on New Motion's part, but it should not preclude you from offering the technology to a person that's in need. You just frankly need to find another supplier. And I'll speak on the insurance side because I've been on the insurance side. If that person's insurance only has an exclusive with New Motion, I would encourage the family or the person to ask for an out-of-network authorization, because you want to be able to give the person access to the technology they need, and the contract relationship between the payer and the provider shouldn't preclude access. So ask for an out-of-network to work with a provider that can provide the technology.
Absolutely. It's like any other piece of equipment, right? If there's a item that I really feel is going to best meet my client's needs, and a supplier says, well, we can't work with that company, then it's my job to inform the client as to all their choices. I, of course, want to respect all the suppliers I'm working with, but my main job is to make sure I'm recommending what's most appropriate and what will meet that client's needs. Jody, I see your comment about some issues with Lucy. I would definitely encourage you to talk to Lucy themselves. There's been some recent software changes. They could probably help identify what the issues are. And I
I'm gonna
think,
just let folks know, I don't know, but I need a bio break and I am on the next session.
yeah, that's all right. And
I
we
have to
got,
hop off.
yes, we are at the last question here. So
I'm
thank
leaving
you
it to
again,
you.
everyone who's hung in there. And we will, if you have any more questions, feel free to reach out to either of us. If you have questions about Lucy, feel free to reach out to Lucy as well. Thank you.